Hello! Do you know anything about the buck converter? Well, if not, you've come to the right place. This video is all about the buck converter. We'll start off with where it's from, like where it's normally used, show you the circuit, use some analogies on, say, what a voltage is, what a current is, and then move on to the circuit again, but it shows how the current flows and give you a better understanding on how this buck converter actually works. Here's a basic power supply. Pretty simple. Buck converters are in almost every power supply. This one pictured here is just for a laptop. Basically what happens is the power supply takes 120 volts out of the wall and steps it down to about 12 volts. Some laptops take in 3.3 volts or 5 volts and then mess with the voltages themselves a little more. Moving on, what is the buck converter? What does it look like? Well, here's the basic circuit. There's 6 basic circuit elements within the buck converter, starting with the voltage source. This would be your 120 volt source from the wall. Going to the transistor. Depending on how fast this transistor switches, it will change your output voltage. Going on, here's the diode, the inductor, capacitor, and resistor. The resistor is where your output voltage ends up lying. Moving on. Here is a good analogy for what a voltage is. In this bucket, you can imagine the more water that's in this bucket, the more voltage potential will be within. Moving on, resistance. The smaller your pipe, the higher the resistance. So if you have a very large resistance, then your water isn't going to be able to flow through the pipe very well. And, well, hold on, we did miss something. What about the current? Well, the current is just how much water is flowing through the pipe at once and how fast it can go. Here's what the buck converter generally looks like. When the transistor turns on, the current is allowed to flow through the circuit, and depending on how fast the transistor is turning on, that's the duty cycle, which is D. So V out is equal to D times V in, which it was Vs earlier in the circuit shown previously. Thank you for watching this presentation, and I hope you learned a thing or two about, well, the buck converter.